Hey guys, so we're going to be talking about the initiation, propagation, and termination steps as it relates to propane and chlorine as it's converted to 1-chloropropane. So I just kind of have a little diagram here. I'm going to try and get it on the screen for you. There we go. Okay. So, one more second. There we go. Okay, hopefully you guys can see that okay. So to start with, we have propane, which is right here, this carbon chain right here. And then we have molecular chlorine, which is right here. There's two chlorines right there. And the only way that this reaction will work is if we add heat or light, and that's what's going to break the bonds of these chlorine molecules, these molecular chlorine molecules. So if we add heat or light, we can break that bond, and you can see with those half-headed arrows that each electron right here in the middle between the chlorines gets pushed over to its respective chlorine molecule, and then each chlorine has just 7 electrons, making it a free radical. So, like I said, now that each one of these chlorines has only 7 electrons, it becomes a free radical and makes it very reactive with other compounds. Now, in this, let me check what we were doing here. So, as these arrows get pushed, and these push these electrons, you get this next step where you have just 2 chlorine free radicals with 7 electrons apiece, and nothing changes with this carbon chain, propane. That is our initiation step. It is endothermic, which means that it requires energy or heat for it to work, and that is all that happens in the initiation step. The next step is the propagation step. With this step, we have this propane carbon chain, and if we have chlorine, which is now that free radical and it's very reactive, if it bumps against the propane in kind of the correct way, it can bond with one of the hydrogens on the end here. So we can see this propane, the end of it, we have this hydrogen. It is going to end up being bonded to this chlorine. So we see the half-headed arrow from the free radical chlorine, which is reactive, bonding with this hydrogen. Both those half-headed arrows are pushing together, and those are going to form an HCl bond. Additionally, we have this C to H bond over here that was initially holding the carbon to the hydrogen. Now that the hydrogen got pushed over to the chlorine molecule, the carbon is going to take its respective electron and bring it back to that, what was that carbon chain, and now you're going to end up with a free radical. You're going to end up with a free radical along this hydrocarbon chain and an HCl over here. And then way over here we still have our other chlorine free radical. So this next step, we can see that this chlorine and the hydrogen became bonded to each other. We still have this free radical chlorine on the outside here. And as I was talking about this hydrocarbon chain, we have this free radical, if we can see that electron on the end of that hydrocarbon chain. So with this propagation step, you have a free radical that is going to react with, well, you're going to have a free radical that's going to react with another compound, and it's going to form a subsequent free radical. Now that, a little bit closer for you guys. Now that we have this hydrocarbon chain that's bonded to this chlorine, now we have this free radical hydrocarbon chain in our HCl right here. Since this is a free radical hydrocarbon chain, it becomes very reactive, and it can bond with any of the molecular chlorines that are in the solution. So it doesn't necessarily have to be this chlorine that's out here that was part of this initial compound. It can be whatever chlorine free radicals are floating in the solution, or molecular chlorines that are together. So it's not exclusive just to this one. So now we have this hydrocarbon chain. It was a free radical. Now it's going to bond with this chlorine. Those half-added arrows will get pushed together and create this bond right here. So now you have your chloropropane molecule. And that can bond in different ways, and we'll get to that in the next video. And then we still have our HCl over here bonded together. And that is the end of that propagation step. This next one is the termination step. And this happens when the concentration of free radicals in a solution becomes very high. And we'll see that since those free radicals are very reactive, they'll start binding with each other. The initial product, as you see in these first two reactions, we have this hydrocarbon chain. It's being bonded with the same hydrocarbon chain. So we're having these propane free radicals are bonded to one another. As a result, we have these half-headed arrows getting pushed towards one another, and that's going to create your bond. The other one is these chlorine free radicals. They each have 7 electrons apiece. They also have these half-headed arrows pushing these electrons together, and you're going to get that that chlorine compound. And then the other one is a little bit different because it's not the same molecules bonding to one another. It's this hydrocarbon chain and this chlorine free radical bonded to one another. But again, you're getting those half-headed arrows pushing them together and bonding those electrons to form your new compound. That is all I have for the initiation, propagation, and termination steps.